In this video, I'm going to go over some applications of rational equations. Before I do that, I would like to remind you of the relationship between distance, rate, and time. If an object travels distance d at a rate r during time t, then the following equations are variants of the same relationship. R is d over t, or d is r times t, or t is d over r. Also useful for these kind of applications is the rate of work. If a job can be completed in t units of time, then the rate of work is 1 over t job per unit time. This will be useful for solving work-related problems. Let's start with the first example. If the same number is added to both the numerator and denominator of the fraction 2 over 5, the result is equivalent to 2/3. Find the number. To solve this problem, let's start out by letting x be that number. Let x be the number. Going over the statements again, if the same number, which is x, is added to the numerator and denominator of 2 over 5, meaning if we take 2 over 5, add x to the numerator and x to the denominator, the result is 2/3. This is a rational equation. Let us solve it for x. First of all, x cannot be -5. And the LCM of x plus 5 and 3 is their product. 3 times x plus 5. If we multiply both sides of this equation by the LCM, we get 3x plus 5 times x plus 2 over x plus 5 is equal to 3 times x plus 5 times 2/3. The left-hand side is simply 3 times x plus 2, because x plus 5 cancel with x plus 5. And the right-hand side is simply 2 times x plus 5. This yields 3x plus 6 equals 2x plus 10. So this means that x equals 10 minus 6, which is 4. Let us check that this indeed satisfies a rational equation. So let's check. X equals 4. What happens when we plug in 4 in the left-hand side? We get 4 plus 2 over 4 plus 5. That's equal to 6 over 9, which simplifies to 2/3. And that's equal to the right-hand side. So x equals 4 is the number we are looking for. Next example. The Tikva River has a current of 3 miles per hour. A motorboat takes as long to travel 12 miles downstream as to travel 8 miles upstream. What is the rate of the boat in still water? Let's start the problem by declaring R to be the rate of the boat in still water. So we say, let R equal boat rate in still water And of course, R is a miles per hour. Now going downstream, we're going with the river, the rate of the boat becomes R plus 3. So we have R plus 3, that's going to be the rate of the boat downstream. And upstream, we have the rate of the boat R in still water going against the river, which has rate 3 miles per hour. So R minus 3 becomes the rate of the boat upstream. Again, R plus 3 and R minus 3 are in miles per hour. The problem says it takes the same amount of time to travel 12 miles downstream as to travel 8 miles upstream. So let's say T downstream equals T upstream. So what I mean here is T downstream is the time it takes the boat to travel 12 miles downstream, and T upstream is the time it takes the boat to travel 8 miles upstream. Let's go back to the relationship between distance, rate, and time. Notice that time is the distance divided by the rate. So I'm going to capitalize on that to create an equation for my problem. T is D over R. So remember, T downstream is the time it takes the boat to travel 12 miles downstream. In this case, the distance is 12 and the rate is R plus 3 equals T upstream, which is the time it takes the boat to travel 8 miles upstream. So that's 8 miles divided by the rate of the boat upstream, which is R minus 3. This is a rational equation. Notice, for this equation, R must be different from plus or minus 3 for the equation to make sense. So we can find the LCM, which is R plus 3, R minus 3, and multiply it on both sides. Or even easier, we can simply cross multiply. If we do that, we get 12 times R minus 3 equals 8 R plus 3. 12R minus 36 equals 8R plus 24. 4R equals 24 plus 36, that's 60, which tells us that R is 15, 60 over 4 is 15 miles per hour. Let's check that R equals 15 is indeed a solution to our equation. 12 over R plus 3 equals 8 over R minus 4. If we plug in 15 on the left-hand side, we get 12 over 15 plus 3. That's 12 over 18, which simplifies to 2/3. If we plug in 15 on the right-hand side, we get 8 over 15 minus 4. That's 8 over 12, which simplifies to 2/3 as well. Since the left-hand side equals the right-hand side, R equals 15 miles per hour is the rate of the boat in still water. Next example is a work-related problem. John can paint the trim on a small house in 10 hours. Tom needs 15 hours to paint the same trim. If both John and Tom work together, how long will it take them to paint the trim? Let's start the problem by declaring T to be the time it takes John and Tom to paint the trim. Let T equals the time in hours it takes John and Tom to paint the trim. John's rate is 1/10 job per hour, and Tom's rate is 1/15 job per hour. This is coming from rate of work. If a job can be completed in T units of time, then the rate is 1/T job per unit time. So, then John's fractional part, or John's contribution, that's the time they spend working together times John's rate, which is 1/10. That's T/10. That's the fractional part that John contributes. And Tom's contribution when working together is the time spent times Tom's rate, which is 1/15. That is T/15. So that's John's fractional part of the job, and that's Tom's fractional part of the job. Together, these two fractional parts should add up to 1. In other words, they contribute to finishing the whole job. So we have T/10 plus T/15 equals 1. The LCM of 10 and 15 is 30. Multiply by 30 on both sides of the equation. 30 times T/10 plus T/15 equals 30 times 1. 30 times T/10 is 3T, plus 30 times T/15 is 2T, equals 30. 5T equals 30, which means that T is 6 hours. Let's check that T equals 6 is indeed a solution to our rational equation. So let's check. T equals 6. The left-hand side is 6/10 plus 6/15. That's 6 times 3 plus 6 times 2/30. This is what happens when you take the least common denominator, 30. That's 18 plus 12/30. That's 30/30 which is 1. And that's equal to the right-hand side of the equation. So we conclude that t equals 6 hours is the time it takes for both John and Tom to finish the trim. Another work-related problem. Hilda can paint a room in 6 hours. Working together with Brenda, they can paint the same room in 3 3/4 of an hour. How long would it take Brenda to paint the room by herself? So we start out the problem by declaring t to be the time in hours it takes Brenda to paint the room by herself. Let t equals time in hours it takes Brenda to paint the room by herself. Working together, it takes 3 3/4 of an hour to paint the room. So together, Hilda and Brenda take 3 3/4 of an hour, which is the same as 15/4 hours, to paint the room. Now, Brenda's rate is 1/t job per hour. And Brenda's contribution, or fractional part, that's going to be Brenda's rate, which is 1/t job per hour, times the total time, which is 15/4 hours, and that's equal to 15/4t of a job. So we found that Brenda's contribution to the entire job is 15/4t of a job. Let's go back and find Hilda's contribution. So Hilda's rate is 1/6 job per hour, and therefore Hilda's contribution is Hilda's rate, 1/6 job per hour, times the total time, which is 15/4 hours. That's the total time it takes both Hilda and Brenda to finish the job. That's 15/24, which simplifies to 5/8 of a job. So Brenda's contribution is 15/4t when working together, and Hilda's contribution is 5/8 of the job when working together. Both fractional parts contribute to finishing the whole job, and therefore they add up to 1. So 15 over 4t plus 5 over 8 equals 1. Notice that t cannot be 0, and the LCM of 4t and 8 is 8t. Let's multiply both sides of the equation by the LCM. 8t times 15 over 4t plus 5 over 8 equals 8t times 1. 8t times 15 over 4t, that's 30, plus 8t times 5 over 8, that is 5t, equals 8t. This gives us 3t equals 30, which means that t is 10 hours. Let's check that t equals 10 is in fact a solution to the equation 15 over 4t plus 5 over 8 equals 1. If we plug in t equals 10 for t on the left-hand side, we get 15 over 4 times 10, which is 40, plus 5 over 8. That's 15 over 40 plus 5 over 8 times 5 over 5, which is equal to 15 plus 25 over 40, which is 40 over 40 equals 1, equals the right-hand side of the equation. So we conclude that t equals 10 hours is the time it takes Brenda to paint the room on her own.